Figure 16.6. So this is a very nice study illustrating one of the more recently developed tools for monitoring species of conservation importance, and that's the use of eDNA or environmental DNA. Typically, it takes a lot of sampling effort to be able to accurately report and record the number of organisms for rare species. They are by definition hard to find because they are rare. What we can see from this example in New Caledonia is the very intense effort that has been used for traditional sampling techniques. So for example, the use of underwater visual census techniques where either divers or snorkelers will record the number of different species and abundance of, for example, coral reef fish. In this particular example, you can see huge sampling effort with nearly 3,000 different sampling sites using underwater visual census. Not only is this expensive and time consuming, it's very frustrating if in fact, despite the large sampling effort, your ability to report on the presence of rare species is actually not that good. Another new technique that has been devised is the use of baited remote underwater video deployments. Basically, this is usually a metal frame sunk to the seabed, baited to attract animals to the frame with an underwater camera and sometimes with light systems, and these are used to record the attendance at the bait over a fixed period of time. So these can be useful supplementary sampling techniques to underwater visual census because they might attract organisms that you would not otherwise see using underwater visual census techniques. Nevertheless, you can see a considerable number of deployments have been used. In contrast, the researchers in this particular paper, which was published by Stefano Mariani's group at Liverpool John Moores University, used environmental DNA at only 22 locations. The take-home message is that the environmental DNA is much more subtle in terms of its ability to be able to pick up the presence of rare species, and you can see it's far more effective at detecting sharks in a greater proportion of samples. It also reports a higher level of shark diversity than the other sampling techniques. So the environmental DNA, of course, relies on a material that's been sloughed off or deposited from organisms as they swim through the environment. So this might be derived from, for example, mucus from the skin of fish, or it might be from feces that they've passed into the water. So the technique, if you like, is able to detect the almost ghostly presence of these organisms despite the fact that you can't actually see that they're there. And in this way, this has offered some revolutionary insights into the true diversity of species that are present in certain locations, and clearly is a technique that has a very important future in terms of conservation efforts going forward.